Morning everybody. Today we're going to just have a review on how to invert a 3x3 matrix. We're going to do this by hand today. You should be able to do this on a calculator as well. I'm not going to go through that one today necessarily, but if you're really struggling to remember how to do that on your calculator, then get in touch and I'll stick something up about how to do it. I think there's quite a few videos on YouTube for the class whiz on how to do it. So inverting a 3x3 matrix, I think if you recall when we did this earlier in the year, I think I said, one second, let's see, what was I saying? Yeah, I think you might remember me going through this and sort of having a bit of a smirk and smile on my face while saying, and then you just do this because you do this, obviously. What a good idea. Yeah, it's not. To be quite honest, I have no idea why these steps work. If I sat down and thought about it long enough, I probably could figure it out. I can't say it's ever probably interested me that much. This is an algorithm to invert a 3x3 matrix. So let's crack on and just think of some things to start with. Okay, so if I want to find out the inverse of a 3x3 matrix, I need to remember how to do a few things. So, for instance, I'll tell you what we'll do. I will do an example on one side, and I'll write another example on the other side of my page, and so you can try each step as we go. So, this is my example here. If I draw a line down the page. So what am I going to use? 2, 3, 4. 2 minus 5, 2 minus 3, 6 minus 3. So that's the example I'm going to do completely. And if I come up with another matrix, which you guys can do, let's do 2, 2, 0. 1, 4 minus 2, 2, 1, 1. Okay, so I'll work this one through as I do each stage. Why don't you try that stage on this one, just to make sure you know what you're doing as we go. Okay, so the first thing you need to do is try and find the determinant of the matrix. Let's call this matrix M. Let's call this one N. So the determinant of M for a 3x3 matrix, hopefully you'll recall, you take the top left one and then times it by this bit in here, the determinant of this bit in here, and then you take the negative of this one and then times it by the determinant left by, so if I cover those rows up, the determinant of those, and then you take the last one, the positive version of 4, cover up the column and row, and you take the determinant of what's left in there. Okay, so just a quick note before we go on. So the first thing I need to do is do 2, and then do times it by the determinant of this bit here, minus 5, 2, 6, minus 3. Now this bit here is called a minor. So for this entry here in the matrix, this is its minor. So I do 2 lots of this, for reasons we'll discuss briefly in a sec. I then do negative 3 lots of, so negative whatever this is, and then use that minor. The minor for this one is I cover up the column, cover up the row. I've got 2, 2, minus 3, minus 3. And then do my last one, plus 4 lots of cover up the column, color up the row, 2 minus 5 minus 3, 6. Minus 3, 6, that's a minus 5. Okay, so just to make sure we're aware, so for instance for that last one here, this thing here is the minor for this entry. This is the minor for this entry, and that's going to be useful in a second, the fact that I keep mentioning that. So if I calculate all of these, I've got 2 times minus 5 times minus 3 is 15. Take away 2 times 6 is 3. And then I've got negative 3. 2 times minus 3 is minus 6. Minus 2 times minus 3 is minus 6. So that's minus 6 minus minus 6, which is minus 3 times 0. I've got that right, haven't I? Yes, I have. Excuse me. And then the last bit, I've got 4 times 2 times 6, which is 12. 12 minus 3 times 5, which is 15. So that's minus 3. So what I'm left with is 6 minus 0 minus 12, which equals minus 6 for the determinant. So, oops-a-daisy. So have a go at doing the determinant for your for matrix n. You should find, if I'm right, that the determinant of n is 2. So just pause the video, do that determinant, and then come back to me, and we'll start looking at the minors. Okay, so next we need to do a matrix of the minors. So remembering what we've just talked about up here, so the minor for this entry here is, when I cover these up, this bit left over here. So I need to do that for every single entry. So what I'm going to do is I'm going to draw a big matrix that's going to be 6 rows high, because that's how many numbers I'm going to have to be able to fit in, and just make it sufficiently wide enough. Don't worry if it's far too wide, just don't make it too narrow. Okay, so looking at the original matrix, let's put this camera up a bit so I can see. Oops, it's a bit difficult to see all the way back up there. So we already know what the first minor for 2 is, it's this. So I'm going to stick this in here, down here, minus 5, 2, 6, minus 3. Just try, oops daisy, and these need to be obviously determinants. So I need to do that for each one. The next one is going to be 2, 2, minus 3, minus 3. Don't worry about this negative sign for now. We'll talk about that in a second. And the last minor for this row is going to be 2 minus 5, minus 3, 6. And then I can keep going. I need to do the minor for this entry next. So I cover up the row, cover up the column, and the minor is going to be 3, 4, 6, minus 3. 3, 4, 6, minus 3. 4, 6, minus 3. And then I keep going like this. So I should get 2, 4, minus 3, minus 3. Then I'm going to get 2, 3, minus 3, 6. And then I'm going to get 3, 4, minus 5, 2. 2, 4, 2, 2. And last but not least, 2, 3, 2, minus 5. Oops. Okay, so that's my matrix of minors, and then the next thing I'll need to do is just work out what each of those things is. So let's just move this onto the next page. So once I've worked out each of those determinants, and this is a good stage to check that you actually got your determinant right for the first one, because you wrote those determinants down a minute ago for the top row. Minus 5 minus 3 is 15. Minus 12 gives me 3, so that one is right. Second one, minus 6 minus minus 6 gives me 0. And the last one should have been minus 3, and that does check out. Good. And if I carry on like this, for the rest of them, I should get minus 33, 6, 21, 26, minus 4, and minus 16. Let me just check those, because I've ended up doing something a bit funny. 2 times 2 is 4, minus, yeah, that's fine. Okay, so this is your matrix of minors. So what I'd like you guys to do is, for your matrix n, can you find out the matrix of minors, please? So you have a crack at that. And I'll just write down the answer here somewhere. 1 second. Okay, so I think what you should get is 6, 5, minus 7, 2, 2, minus 2, minus 4, minus 4, 6. If I've got one of these signs wrong, I do apologise. Okay, so just make sure you can get that sorted and then come back to the video. Okay, so now we've got the matrix of minors, what we need to do next is just change it into the matrix of cofactors. And what we use for this is this odd looking matrix here, using the word matrix in the loosest term of the word probably. So essentially what we're going to do is we're going to just hit this matrix with these cofactors. We're going to put a plus sign on, we're going to hit, basically, well, this is going to be times by positive 1, this is going to be times by minus 1, this is going to be times by positive 1, times by minus 1, etc. In other words, if you are in one of the diagonals, your sign doesn't change. If you're one of these, your sign does change. So the cofactor matrix, so this is step 3. So cofactor, we are going to have 3, 6, negative 16, negative 3, 26. So if you put the diagonals in straight away and don't change anything, then stick in the other numbers but change the sign. So 0 stays as it is, this becomes 33, this becomes a minus 21, and this becomes 4. So can you do that for yours as well? You probably beat me to it. Keep the diagonals the same, and then change the other signs. Okay, one of the last things we need to do now is do transpose. So step 4, transpose. Transposing a matrix is really easy. Basically the diagonal stays the same, and once the diagonal stays the same, all of these reflect in that central line. Yes, Max? I do like that rectangle, that's very nice. Okay, so let's transpose my cofactor matrix. So I'm going to write my diagonal in 3, 6, minus 16, and then I'm going to reflect all of these other ones across that line. So this becomes 0, that becomes 33, this becomes 26, that becomes minus 3, and this becomes 4 and minus 21. You did a square, did you? Good. Can you guys just transpose your matrix, please? So making sure you keep the diagonal the same, and then reflect the others across the diagonal. Okay, and so we are pretty much there now. The last thing is actually just to write the matrix down. And what we need to do is times by the determinant. So m of minus 1 is, well, whatever the determinant was, it was minus 6. So m of minus 1 is 1 over minus 6. So I have to do 1 over the determinant, just as I do when I do inverse of 2 by 2 matrices. So I've got 1 over minus 6. and then I need to do the matrix next to it. At this point you can bring some of that inside to simplify it. It's really up to you, and it depends what situation you're in, depending on what you're going to do next. Okay, I'll help you in a sec. In this case, I don't draw my textbook. I wouldn't bring the 6 in here because I've got these couple of numbers. Well, I've got a few numbers here which haven't got those multiples of 3 in. I'd probably just leave it on the outside, but just make possibly change the signs in here to get rid of the minus sign. It's just up to you. It's not really too important. You can leave your answer with the determinant outside. So for your one, obviously you just need to put the determinant on the outside and then write the matrix. So for your matrix, you should have whatever the determinant was. It was 2, wasn't it? So you should have 1 over 2, and then you've got 6 minus 2 minus 4 minus 5 2 4 minus 7 2 6. I think for that one I might bring the 2 in. There's quite a lot of even numbers in there, and these would just be minus 5 over 2, etc. Okay, so that is the process of doing the inversion of a 3 by 3 matrix. If I pull that camera up, I can probably see a bit more what's going on. So first step, determinants. Second step, working out the minors. Third step, hitting it with cofactors. Fourth step, transpose. And then fifth step, you just bang it all together. So I think someone should have a prize for who comes up with the best way of remembering D, M, C, T, and whatever we're going to call the last step. Okay, so what I'd like you guys to do is practice that skill, because you need to be able to do it in your exam. You can, if it says, I'm not sure if it has a command word for saying, can you do this without your calculator? It might do. The easiest way for them to test this skill in the exam is by making sure that one of the original entries isn't a whole number. If one of these original if one of these entries is a letter instead of a number, you can't put this into a calculator. So if it's just numbers and they say invert it, if they don't tell you how to invert it, you do it on your calculator straight away because it takes seconds. If there's a letter in here, you can't do it on your calculator, and that's how they'll most probably test the skill for you to be able to do this. Okay, so sorry that was a bit long-winded today, and I'm sorry about numerous interruptions. I now need to sit down and draw some numbers with my son. What I'd like you guys to do is exercise 2.1. Can you do all of question 1? That's doing this whole process 6 times, but you'll be surprised how quick you get at this towards the end. And then also, can you do question 4? And I think that will be sufficient for today. Yep, I'm happy with that. Okay, so exercise 2.1, question 1, question 4. I'm going to stick those sheets up as well now before I forget. Okay, thanks very much, guys, and I'll speak to you again tomorrow. Bye-bye.